let's start 12.4. So if this is my arc, right? Okay, so the first thing we have to identify is where are my lines? Where is the intersection of my lines? My intersection of my lines is on the outside. And are we looking for degrees or segments? We're looking for degrees, right? So my measure of angle 1 is going to be equal to half A minus B. Now we know that if my intersection of lines was inside the circle, it would be measure of angle 1 equals half of A plus B. Oh, and your A always wants to be the bigger one, preferably, and your B the smaller arcs. And if my intersection of lines was on the circle, then it would just be measure of angle 1 equals half of A. So we're going to have, what's my measure of angle 1? Z equals half of A 133 minus 69, whoops, which is 64, right? 64. And what is half of 64? It's 32. So my answer should be 32, and it is. All right, so let's move on. Okay, they want you to find x and y. Okay, so we see how this x is a arc, right? Well, it's an arc that is also the same measure as this one, all of these. So really we have 1, 2, 3, 4, 5, 6 arcs that are the same. So how many degrees are in an entire circle? 360, right? So if each of these arcs were divided evenly into 6 pieces, well, what's 360 divided by 6? That's 60 degrees. So my x should be 60. Now, we also know that the interior angles of a hexagon are also 60 degrees each. Okay, so if this is, why is it not right? Okay, so if this was 60 degrees, and we know that this line is tangent, okay, it says it right here, by the way. So it says that this line is tangent, so if it's tangent, this is 90, this little piece is 90, but this other piece is 90 as well, right? So what is this entire thing gonna be? It's gonna be 180, right? It's the linear pair theorem. So now let's write a little bit smaller. Now, if this is 60, then what is 180 minus 60? Well, that's 120. And what's 120 divided by 2? 60. So that means this little piece is 60. This little piece is 60. And this little piece is 60. So if this piece right here is 60, well, what is going to be the inscribed? Oh, wait, yeah. So what's my, oh, I apologize. So no, I made a mistake. So I apologize. If this is 60 and I know that this is tangent right here, well, if this piece is 60, what is this piece going to be over here? It's going to be 30, right? So what is my measure of y? It's 30. Apologies for that. So we can go more over that in person. So my x should be 60, my y should be 30. 60, 30. Perfect. Okay. So find the value of each variable. Okay, so let's find the value of each variable. All right, so let's find, I think it'll be easier to find y first. So let's find y first. All right, so y is a what? Is a chord, right? I mean an arc, correct? Well, where is that intersection? Where's the intersection of lines? It's outside, right? So that means my measure of angle 1 is going to be 1/2 of A minus B. So my measure of angle 1 in this case would be what? 51 half. What's my A? Well, this has to be my B, correct? This is going to be my B. So what's going to be my A? It's going to be this entire thing over here. So I know, oh no, I apologize. It's not. This is my angle 51, right? Boom, boom. So what's my intercepted arc over here? It's 180. And what is this little arc over here? The B? It's just y. So let's put that there. So this is my A, that's my y. So 180 minus B. So let's multiply by 2 to get rid of this. Multiply by 2, so that's going to be 102 is equal to 180 minus B, or my y, right? Y. So minus 180 minus 180, that's negative 78, and negative 78 equals negative y. It's just y equals 78. Okay, so let's see, is that correct? Y equals 78. Okay, so now let's find my x. Well, this is 78. So let's put that there. 78. Okay, well, okay, and now to find these guys, I know that this guy and this guy are going to be equal. I'm going to erase some of this, see if it'll help me out. Okay, let's see. I'm going to erase some of this. I know this is 78. Okay, how can I find x? Okay, I know this piece right here is, because this entire thing is 180. So this piece is what, 70. 70. Oh, guys, this is the, okay. This, where is my intersection of lines? See, this stuff is tricky. You gotta practice, because even me, I mess up all the time. This is my intersection of lines, right? It's on the inside. So I'm gonna need this arc, and I'm going to need this arc, which is what? 180. So now when my intersection of lines is inside, my measure of angle 1 is equal to half of, what's my A? My A and my B, it doesn't really matter because we're gonna add them, right? A plus B, perfect. So now my measure of angle 1 is x, half, what's A? 180 plus 70, which is, what is this? 250. So what's half of 250? It's 125. So my x should be 125, perfect. Okay, this one's tough, right? So this one's definitely gonna go on your test. So make sure you guys study this one and we can go over it in class because that one's tough. All right, so what is the value of x? All right, they just want the value of x. Okay, so I guess they don't want y. Okay, so this is how they're gonna try to trick you guys. They're gonna make you think that, well, the way to solve for y is by doing what? Measure of angle 1 equals half of a plus b, but they don't want a degree. They don't want y. What do they want? They want x. And what is x? Is x a degree or a segment? It's a segment, right? So what segments is the x on? What is this called? A chord. And what is this called up to here? A chord. So let's just, what is the formula for segments of chords? It is A times B equals C times D. Now, if I'm gonna name this my A, this x has to be my B. And if I'm gonna name this my C, this has to be my D. So 10x equals 21, 7 times 4, 7, 4, 20, oh no, 28. 28, so divide by 10, my x should be 2.8. Is it? Yep, 2.8. Perfect. Okay, so what about this? Okay. They want me to find my x and my y. Okay, so once again, where is my intersection of lines? It's outside the circle. But do I want degrees? I don't see any little degree signs at all. I don't see any degree sign whatsoever. So that means they obviously must want segments. So what type of lines do I have here? Well, I have this line, which is what? A secant. And I have this one, which is a tangent. So I'm gonna need my secant tangent theorem, which is exterior 1 times hole 1 equals tangent squared. Okay, so what's my exterior 1? This is my exterior 1, and this whole thing is my hole 1, which is, so it's going to be 6, and my hole is not 32, it's 32 plus 6, which is 38, equals, what's my tangent? Y, right? Y is my tangent. So y squared. Okay, so what's 6 times 38? 6 times 38 is 228. Wait. 228 equals y squared. Square root of 228 is, wait, do they want it as a decimal? Let's see if they want it as a decimal or as, yeah, they do. So they want it as a decimal, so 15.1. So my y is 15.1. Which is it? Yep. Okay, so now they want to find our x. So now let's find our x. Well, our x is another segment, right? But now I have this segment, which is a what? This is a secant, and this one's a secant. So I'm going to use the secant theorem, which is exterior 1 times hole 1 equals exterior 2 times hole 2. So I'm going to make this my exterior 2, and this whole thing my hole 2, because I already have these up here, so why would I change anything? So my E1 is 6 times 38. My E2 is 8, and my hole 2 is not x, it is x plus 8. X plus 8. So 6 times 38, we already discussed it was 228. 8x plus 64. So minus 64, minus 64. Let's put this down here. So my 8x is going to equal 164. What is 164 divided by 8? 20.5. So my answer should be 20.5. Is it? Yep, 20.5. So they're going to give you a bunch of stuff. So here, to figure this one out, you first had to use this tangent line. And then to figure out this x, you had to have used, you could have done this one, but I didn't want to use that one. I think this is a lot easier. So it's up to you guys. Okay. So the diameter, okay. So they want to know the diameter, that's the question. So therefore, they want to know what this value is right here, this value. So let's mark this as x. So where is the intersection of lines? It's outside. They don't want degrees, right? They want segments. So I have to identify, okay, what type of segments do I have? I have a tangent over here, and I have a secant over there. So I got to use the secant tangent theorem. So E1, exterior 1, times hole 1 equals tangent squared. So what's my exterior 1? 15. And what's my hole 1? It's 15 plus x. So x plus 15. And my tangent is 25. It's 25 squared. So 15x plus 225. What's 25 squared? 625. 625 minus 225 minus 225, 0, 0, 4. So 15x equals 400. So what's 400 divided by 15? 26.7. So my answer should be 26.7. There we go. Perfect. Okay. So now let's do this one. They want me to find x and y. Okay, so let's find my x first. So in blue, no, in orange, well, let's find my x. So where is the line of intersection? Outside the circle. Now we know we don't want degrees because I don't see any degrees, so we got to use segments. So what type of lines do I have? Well, let's focus on x first. So I have an x here, which is a tangent line, and I have this line segment right here, which is a secant. So I had to use my secant tangent theorem. So now this is gonna be exterior 1 times whole 1 equals tangent 2. So my exterior 1 is 3. My whole 1 is going to be 15, right? Because it's 12 plus 3. So 3 times 15 equals tangent, which is just x. So x squared is equal to 45. So what's the square root of 45? 6.7. Is it 6.7? 6.7. All right, now, I don't want to use this tangent line. Why not? Because it was a rounded answer. Rounded answers can possibly lead to a mistake. So I'm just going to use this, which has exact numbers that I know, and then this, and this is a secant line, right? So it's just going to be my secant theorem. So this is x2, and my whole 2 is going to be y plus 6. So exterior 1 is 3 times 15 equals 6 times 6 plus y. Or I guess y plus 6, that's how I've been doing it, right? Doesn't really matter either way. So 3 times 15, we already established is 45. 6y plus 36 minus 36 minus 36. 9 equals 6y. That doesn't seem right. Oh, yeah, it is. Okay. Divided by 6, divided by 6. So 9 divided by 6 is 1.5. Perfect. Okay. And that's my answer, 1.5. Perfect. Okay.